Hi everyone, in this video we're going to look at the unit circle. So this is 4.2, it's going to be the first video and we're going to cover outcome T2. Now if you recall from last year in the grade 11 course we looked at the unit circle briefly and we did some work with this as well. So I've taken the liberty to show you a diagram of the unit circle where you have a circle and it has the radius of 1. So the unit is the 1. Now I've labeled the points at the axes, so at the X and Y axes, just in terms of X and Y, so you could see that here. Now, we use the notation P of theta to indicate a point on the circle. So for example, right here, a point on the circle will be here, and we have, I can call this P of theta, sorry. It means this point is going to be defined in terms of the angle. And here we've got the point could also be given in coordinate point, X and Y coordinates. So I'm going to show you where the triangle is from. So here we've got this triangle. If I take this point and I draw a line from the origin to the point on the unit circle, I see that this also has a radius of 1. Now I can take this line and I'm going to drop it straight down, and that's going to be how high it is or how tall it is, and that's going to be defined in terms of y. So this is a y value. And then right here, from here to where this line drops, this is my x value. So now I've got my right angle triangle in here, and I'm going to relate this to this equation, Pythagorean theorem, but the radius is going to be 1. Now, this is the equation of the unit circle, or a circle that has a radius of 1. Now, what would your wild guess be if the circle had a radius of 2? Any ideas? Okay, I'll give you 1 second to decide. Well, okay, 1. All right, so the 1 correlates to that 1 here. So where would that 2 go? Ta-da! Right there. So this would be the equation for a circle with the radius of 2. Now, these are some ideas that we're going to visit that we may have already visited in the past if you can recall this from grade 11. So you've got P equals the point XY. P theta is going to be in terms of the angle. So we have cosine theta, that's going to be the X value part, and sine theta is the Y value part. This is the Pythagorean theorem where you have a radius of 1, and this is pretty much the same thing. So you see if the X correlates to the cosine and the Y is the sine theta, then we can just write this formula here and it all refers to the same idea. So let's have a look at this first example, and we've done this in grade 11, so this should be a review. Now, 2/3 y is a point on the circle. We need to find the value of y. So we're going to use the fact that x is 2/3. It's a positive number. So we know if we kind of just take a quick sketch and look at where 2/3 is, so we can kind of imagine it's going to be here. So it could either be somewhere here or down here, if this is the 2 points on our unit circle. All right, now we can use x squared plus y squared equals 1 to figure out what y is going to be. So we need to determine y using this formula. So let's plug in what we know and solve for what we don't know. So we've got 2/3 all squared plus y squared equals 1, and figure this out. This is 4/9 plus y squared equals 1. Subtract 4/9 on both sides and solve for y. So we've got, we've got y squared equals 1 minus 4/9. Sorry, here I'll scribble that out and write it out nicer so you can see. And then this is 5/9. So now I've got y squared is equal to 5 over 9, and I'm running out of space. I wish I didn't run out of space, but I tend to write a little big. So I'm going to take this and I'm going to carry it over here. So I've got y squared equals 5 over 9. Now, in order to isolate y, I need to square root both sides. So I get y equals the square root of plus or minus 5 over 9. So make sure you have that plus minus in front of the square root, not inside. And take the square root of what you can. So I'm going to have plus minus root 5. I can take the square root of 9, which is going to be 3. So these are the two positive. I've got a positive and a negative value that will satisfy that x value on the unit circle. Okay, so this would be the negative root 5 over 3, and this would be the positive root 5 over 3. And my x value in both cases would be 2 over 3. So there's 1 point, and 2 over 3, there's my other point right there. I have a comma, and this is my, I can imagine my unit circle right there. Okay, now for the next question here, we've got determine whether or not the point 2 over 5, 3 over 5 is on the unit circle. We need to justify our reasoning. So another way we could ask this is say, does this point satisfy x squared plus y squared equals 1? And we choose this because this is the formula for the unit circle. Also a note, I want you to make sure you're working down, not across, because this is a proof essentially. So we'll start off with x squared plus y squared equals 1. Now, we don't know if this is the case or not, right? So I'm not going to use an equal sign. I'm just going to put a dotted line there for now so that I can see whether or not my left-hand side is going to equal my right-hand side. Okay, so my left-hand side, I can continue working on this side. Let's take these values and plug them in here. So I've got 2 over 5 squared plus 3 over 5 squared, and that is 4 over 25 plus 9 over 25, and that equals 13 over 25. So does this equal to the other side? No, it does not. So I can say this does not equal 1. Left-hand side does not equal right-hand side. Therefore, this point, so the point 2 over 5, 3 over 5 does not lie on the unit circle, or I could say is not on the unit circle. Okay, is not. All right, so that's it for this one, and I'll catch you in the next one.